So not only can we differentiate with these parametric equations, but we can also integrate. And we're going to look at an example of that right now. It says find the area under one arch of the cycloid x equals a times t minus sine t, y equals a times 1 minus cosine t. Now, a cycloid is created by taking a circle, and you can see here in the image I have, there's this point on the circle. So it would start at the origin. So at time t equals 0, let me turn my pen on. This point is here at the origin, rather not in this case, it's more the angle 0. T is at the origin, and then we're going to take this circle and just spin it around until that point hits the x-axis again. Now with the circle, and you should know this from past math classes, has an angle measure of 360 degrees, which in radians is 2 pi. That tells us that if it starts at t equals 0 degrees, for a full rotation of that circle, it's going to go around 360 degrees or 2 pi radians. So we're looking at t values between 0 and 2 pi. So what I'm going to do is I'm going to integrate, but with respect to t. So we're looking at t values from 0 to 2 pi. And you can set it up much the way you would just integrating a regular Cartesian equation. You'd be looking at y dx in here. We're going to replace y with what it equals, so it'll be in terms of t, and then we're going to do the same thing with dx. Since x is equal to a times t minus sine t, dx is a times 1 minus cosine t dt. So now I can go ahead and replace, so we will integrate with respect to t. So I have a times 1 minus cosine t times a times 1 minus cosine t dt. Now I'm going to go ahead and multiply through. The a times a, which equals a squared, is just a constant. So I'm going to bring that in front of the integral. And then inside, I'm just going to multiply 1 minus cosine t by itself. So that's going to give me 1 minus 2 cosine t plus cosine squared t. Now the first two terms here are ready to go. We can integrate them as is, but that third term, I'm going to rewrite it using a trig identity. Cosine squared is the same thing as 1 plus cosine of 2t over 2. So what I'm going to do is I'm going to break this into two separate equations. It'll be 1/2 plus 1/2 cosine 2t. The 1/2 I'll add to the 1. So that's going to give me a squared. And we're integrating from 0 to 2 pi. And we have 3/2 minus 2 cosine t plus 1/2 cosine 2t. So now we can go ahead and integrate this. And hopefully I have enough space here. So we're going to have 3/2 t minus 2 sine t. Now for this one, because it's a 2t, we'll have to be multiplying it by a 1/2. So when we integrate it, we'll have plus 1/4 sine of 2t. And we're going to look at that from 0 to 2 pi. So starting with the 2 pi, we've got 3/2 times 2 pi. So that's going to just be 3 pi. Sine of 2 pi is 0, so the next term here is a 0. Sine of 2 times 2 pi, so sine of 4 pi, that's also a 0. Now let's move to the 0. 3 halves times 0 is 0. Sine of 0 is 0. Sine of 2 times 0 is still 0. So with all that, we're simply left with a 3 halves inside the brackets. Or sorry, we have a 3 pi, not a 3 halves. 3 pi inside the brackets. So we have a squared times 3 pi, or 3 pi a squared. And depending on that value a, obviously, that will give us the area. Now, in the next example, we're going to look at one of the applications of integration here, and we are going to find the length of a curve. And it says in the definition, if a curve is defined parametrically, so x is equal to f of t, y is g of t, on an interval, we can find the length of the curve by the formula that's given here, okay? We're going to integrate from a to b, and it's going to be the square root of f prime squared plus g prime squared dt. So it's very similar to the formula to find the length of a curve that we looked at before. In this case, though, both x and y are defined as functions of t. So to find f prime of t, we're just going to differentiate the equation here for x. So we're given, I'm jumping ahead of myself, find the length of the curve. X equals 8 cosine t plus 8t sine t. Y is 8 sine t minus 8t cosine t. And then the interval is going to be from 0 to pi over 2. And I have a picture of it here. The curve is in red. So let's go ahead and differentiate here. We're going to have negative 8 sine t. Then we have to use the product rule. So it's going to be plus 8t cosine t. And then it's going to be 8 sine t. So it's this part times the derivative of the sine, and then it's sine times the derivative of the first part. Conveniently enough for us, negative 8 sine t and positive 8 sine t cancel, so we're left with just 8t cosine t. Now we're going to do the same thing here for y. So y is equal to g of t, so g prime of t. We're going to take the derivative here, so we get 8 cosine t. Then just to keep things simple, I'm going to treat, we're going to use the product rule again. I'm going to treat this as negative 8t there. So we're going to take negative 8t times the derivative of cosine t. So that's going to be negative 8t times negative sine t. So that's going to be a positive 8t sine t. Then I take cosine t times the derivative of negative 8t. So that's going to be negative 8 cosine t. And similar to what happened with f prime, here we're going to have the 8 cosine t and the negative 8 cosine t cancel out, so we're just left with 8t sine t. So to find the length of the curve, we're going to use that formula. So we're going to integrate from t is 0 to t equals pi over 2. And we're going to have the square root of f prime squared. So it's going to be 8t cosine t squared plus g prime squared. So it's going to be 8t sine t squared dt. So inside that radical, we've got 64t squared cosine squared t plus 64t squared sine squared. And if I factor out the 64t squared, we're left with cosine squared plus sine squared. And that's a trig identity we've used quite often. Cosine squared plus sine squared is just equal to 1. So we can replace that parenthesis with a 1. So that leaves us with just 64t squared inside the radical. Oop, I just noticed. I randomly changed this to a pi over 4. Let's fix that. I think I had 64 on my brain. There we go. Let's change that back. So we have the square root of 64t squared. And the square root of 64t squared is just going to be 8t. So when we integrate, we're going to have 8t squared over 2, or just 4t squared. And we're going to look at that from 0 to pi over 2. So I've got 4 times pi over 2 squared minus 4 times 0 squared. So the second part obviously is 0. We got 4 times pi squared over 4. The 4's will cancel, so we're just left with pi squared. So the length of that curve is pi squared. And we're going to do one more example in this section, but I'm going to save that one for its own video.